area of composite shapes. Composite shapes are made up of more than one basic shape. So the word composite, think of composed, made up. So this shape here is made up of a rectangle and a semicircle. This shape is made up of a square with a triangle taken out of it. So composite shapes can be based on shapes being added together or subtracted from each other. And sometimes it can look like either would work, and in that case you can use either strategy. So we find the areas and we add or subtract them. And we need to show appropriate working to make it really clear what it is that we are doing. So our steps are identify the shapes and the correct formulas. Now you do have two options as to how to do it. You can write an overall formula for the whole area of the shape by combining both formulas. So here I've got a semicircle and a rectangle. So the area of the whole shape is the area of the semicircle plus the area of the rectangle. Area equals. Now the area of a semicircle is pi r squared divided by 2, and the area of a rectangle is length times width. So you see I've written the formula for the whole shape all at once. You can do that, or you can identify the shapes and find the areas separately and then deal with adding or subtracting. But if you do that, you've got to be really clear about what you're doing and label your working. So once we've written formulas, we substitute in values. And the reason I chose a semicircle is sometimes it's not obvious what the radius of the semicircle is, but the measurement will always be there. You can see this length here is 14 centimeters, which is the same as that. So the diameter is 14 centimeters. So the radius of the semicircle must be 7 centimeters. And you might like to write that somewhere over here. Radius is 7 centimeters. So the area then is pi times 7 squared divided by 2. That's for the semicircle. Plus length times width, 17 plus 14. And you would then likely work those out separately. Oh, that's not, careful, that's a times, length times width, sorry about that. Or if you've got your green calculator would quite happily work that out for you if you entered it exactly as written. So we have a fraction, we have pi times 7 squared on the top, oops, and divided by 2. Moving out, we have plus 17 times 14, and we have 314.969. So to 2 decimal places, that would be 314.97. We come back to area. We were in centimeters, so in area we're centimeters squared, because we're counting the little squares that fit into the shape. Solve with units. And our units for area will be units squared. So that is how to do it with a combined formula. If you're feeling comfortable, you might not need to watch this bit. I'll just do this with two separate formulas. Identify our shapes. I've got a square because this is 4 times 4 and a subtracted triangle. If you prefer to find the areas of the basic shapes separately, that's fine, but you must label what you're doing. Area of square is side squared or length squared. That's not a 5, that's an S for side, or length if you prefer, L, which is 4 squared, which is 16. Units are meters, so it's meters squared. Area of triangle is half base times height, or you can do base times height divided by 2, of course, which is half times, now the height of the triangle is 2, the base of the triangle is 4, and that's 4 meters squared. Area of the shape is the square minus the triangle (16 minus 4 is 12 meters squared). So you can see if you set it out separately, there is more working because you have to label what you're doing. Because if you just write A equals side squared, you haven't said which area you're finding. A equals is fine here because it asked for the area of the whole shape and you're finding the area of the whole shape. But if you're finding them separately, label what you're doing. So it's easier, I think, if you combine them. We could have combined this one, just A equals side squared minus half base times height. That would have been just okay.